Hey everyone, I hope you're doing well. It's Mr. Irwin here with today's lesson. Today we are going to factor expressions, specifically numerical expressions, so numbers for every term here. Really, factoring is the opposite of what we did last time. Last lesson, we worked on distributive property where we took a value outside of parentheses and multiplied it into the parentheses. Today's the opposite. We're going to find a common factor and divide that common factor out of the expression. So our first example is on the screen. Please copy it down on a sheet of paper and work it out with me as we go through it. Our expression is 4 plus 6. Well, to factor an expression, I need to find the greatest common factor of all the terms in the expression. So the terms here are 4 and 6. So we're going to start by finding greatest common factor. Let's list the factors of 4. 1 is a factor of everything, and what's its partner? 1 times what gives us 4? Well, 4. 4 is even, so it is divisible by 2. 2 times what gives us 4? 2 times 2, and there's my duplicate. So the only factors of 4 are 1, 2, and 4. We're going to do the same thing with our other term 6, starting with 1 and 6. 6 is even, so it is divisible by 2. 2 times what gives us 6? 3. And when we move on to test divisibility by 3, we have our duplicate. Factors of 6 are 1, 2, 3, and 6. The greatest common factor of both then is 2. That is the value that we are going to divide out of both of these terms. The greatest common factor is going to become the coefficient on a set of parentheses. So it is the number on the outside touching the parentheses. Now, because we are factoring, think of factoring as another word for dividing. We are dividing that coefficient out of both of these terms. So we're going to start with our 4. We're dividing a 2 out. 4 divided by 2 leaves me with a term of 2. I'm going to drop whatever operation I have in my original expression. In this case, it's addition, so bring down your plus sign. And now, factor a 2 out of 6. 6 divided by 2 leaves me with a term of 3. And we have just factored our first expression. 4 plus 6 will factor to an equivalent expression, 2 times the quantity of 2 plus 3. Now, if you want a quick way to test your work to make sure you did everything correctly, take your result of factoring, 2 times the quantity of 2 plus 3, and use the distributive property like we did in a lesson earlier this week. Distribute the coefficient 2 to the first term 2. 2 times 2 is 4, plus distributing to the next term, 2 times 3 gives me 6. And if everything was correct, you should get the same expression you started with. All right, on to our next example. 3 terms here, 25 plus 40 minus 5. We are using greatest common factor to rewrite this expression. So our first step, find the greatest common factor of all the terms. In this case, 25, 40, and 5. So on the side of our page, we're first starting by finding the factors of 25. Starting with 1 and 25. 25 is not even, so it will not divide evenly by 2. 2 plus 5 is 7, which is not a multiple of 3, so it is not divisible by 3. Counting by 4s, we would never reach 25, so it is not divisible by 4. And then 5, it does end in 0 or 5, so it is divisible by 5. 5 times 5 gives me 25, and there's my duplicate. So only 3 factors for 25, 1, 25, and 5. Our next term is 40. Let's find our factors of 40, always starting with 1 times itself. So 1 and 40. 40 is even, so we can do 2 and 20. 4 plus 0 is 3. 4 plus 0 is 4. 4 is not a multiple of 3, so 3 is not a factor of 40. 4 will work. 4 times 10. It ends in 0, so 5 will work. 5 times 8. 6 and 7 not factors, and 8 is my repeat. So there are all my factors of 40. We have a third term, so now I need factors of 5. 1 and 5. It is not even, so 2 won't work, 3 won't work, and counting by 4s, you'll never say 5, so 4 won't work, and 5 is my duplicate. So I'm looking for the greatest common factor, the largest value that appears as a factor for all 3 of these numbers, and this one is 5. That greatest common factor will become the coefficient of a quantity, the number outside of parentheses. And now I want to divide all my terms by that coefficient to get the remaining terms inside of those parentheses. So factoring a 5 out of 25. 25 divided by 5 is 5. Bring down your operation, which is addition, a plus sign. Now factor a 5 out of 40. 40 divided by 5 is 8. Bring down our next operation, which is subtraction. And now factor a 5 out of 5. 5 divided by 5 is 1. You have generated the equivalent expression 5 times the quantity, 5 plus 8 minus 1. All right, next example, 24 plus 36. We are factoring this expression, so let's find factors of 24. Please complete this problem with me on your own sheet of paper. 1 and 24, first factors of 24. It is even, so 2 will work. 2 and 12. 3 and 8, and 4 and 6 will give us all the factors of 24. Now 36, there's lots of them. 1 and 36. It is even, so 2 will work. 2 and 18. 3 will work. 3 and 12. 4 and 9, and then 6 and 6. So the factors of 36, you should get 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now, what is the greatest common factor? The largest value that appears in both is a 12. So I'm going to factor that 12 out of my initial expression, 24 plus 36. 12 becomes the coefficient. We're going to divide that coefficient or factor it out of each of these terms. 24 divided by 12 is 2. Drop your addition sign. 36 divided by 12 is 3. You get the equivalent expression 12 times the quantity, 2 plus 3. Now look at this question below it. What is another way to rewrite this expression? Is there another way I could have factored it? Now I initially factored it using the greatest common factor, but you could factor an expression using any common factor. Let's go back and look at our factor list. Is there another value that appears in both lists? Well, I see 6. So I could factor a 6 out of this expression. And if I factored a 6, what would my expression look like? Remember, our common factor will become our coefficient outside of parentheses. And now let's factor that coefficient out of each of our initial terms. 24 divided by 6 is 4. We drop our addition sign. And 36 divided by 6 gives us 6. So another way to factor that expression is 6 times the quantity of 4 plus 6. Can we find another way? Is there another common factor I could factor out? Yeah, I see 4 is common to both these terms. Let's factor a 4 out. Make 4 a coefficient on our quantity. Factoring a 4 out of 24. 24 divided by 4 is 6. Drop our plus sign. 36 divided by 4 is 9. Another way to factor this expression. 4 times the quantity of 6 plus 9. Do you see any more common factors? Yeah, I could factor out a 3. Make 3 your coefficient. When I factor a 3 out, 24 divided by 3 is 8, plus 36 divided by 3 is 12. So there is a fourth way to factor that expression, 3 times the quantity of 8 plus 12. And boys and girls, guess what? Yeah, you saw it. There is another common factor that we could factor out of this expression. I could factor out a 2. If I do that, 24 divided by 2 is 12, plus 36 divided by 2 is 18. So 2 times the quantity of 12 plus 18 is a fifth way to factor that expression. So you're going to run into circumstances where they ask you to factor an expression using the greatest common factor. In that case, this is your only answer, 12 times the quantity of 2 plus 3, because 12 is the largest value that I could factor out of both 24 and 36. But there will be occasions where you'll be asked to factor an expression in multiple ways. And in that case, you could use any common factor, and any of these would be viable ways to factor an expression. All right, on your screen, you should see 3 more expressions. I want you to go ahead, pause the video, factor these 3 expressions on your own, and then come back and play the video to check your work to see how you did. All right, I hope you gave yourself enough time to complete these problems on your own. Let's go ahead and check to see how you did. Whoops, sorry, there goes my camera. All right, starting with 7 plus 21. Let's factor 7. The only factors are 1 and 7. Factors of 21 are 1 and 21 and 3 and 7. That means my greatest common factor is 7. So 7 will become my coefficient. If I factor out a 7, 7 divided by 7 is 1. Drop our addition sign and now factor a 7 out of 21. 21 divided by 7 is 3. Your factored expression, 7 times the quantity of 1 plus 3. Next problem, we have 45 and 27. Let's go ahead and factor. We get 1 and 45. 2 won't work, but 3 will. 3 times 15. 4 does not work, but 5 will. 5 times 9. 6, 7, or 8 is no go, and 9 is my repeat. Now on to 27. Our factors are 1 and 27. 3 and 9. 4 won't work. 5 won't work. 6 won't work. 7 or 8, but 9 is my duplicate. So the greatest common factor here is 9. That becomes my coefficient outside the quantity. 45 divided by 9 leaves me with a term of 5, minus 27 divided by 9 is 3. Numerical expression, 9 times the quantity, 5 minus 3. All right, final problem, 50 plus 24 plus 18. We have 3 values that we need to factor, 50, 24, and 18. Starting with 50, factors are 1 and 50, 2 and 25, 5 and 10. Those are all your factors of 50. 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then 18, 1 and 18, 2 and 9, and 3 and 6. So what is the largest value that appears in all of these? And I'm seeing 2 as the greatest common factor. So make 2 your coefficient and factor a 2 out of all these terms. 50 divided by 2 is 25. Bring down your plus sign. 24 divided by 2 is 12. Bring down your plus sign. 18 divided by 2 is 9. So your factored expression, 2 times the quantity of 25 plus 12 plus 9. Please complete the independent practice assignment for factoring expressions. Take a picture of your work and upload that image file for submission. Take care, everyone.